Okay, this is the Fiesta moderately large turbo version 2, or I guess part 2. So I have the wideband installed in the car. I have the gauge mostly finished. I think I may have gotten a bad, gauge pod. I think I've gotten a bad gauge. I'm taking the connector in and out, and the power is coming and going. So that's been a struggle to figure out what's going on there. I'm gonna reach out to my rep at Turn 14 and have him hopefully swap it out. I don't know, but whatever. It's at least mostly done. I just like the little particulars that need to get ironed out. What you see in front of you is my flaking vacuum rig. I have the intake manifold taped off, the ports, which if you haven't seen these on the Fiesta, they're very cool. They have 2 ports per, and I may have already talked about this in the other video, but they're 2 ports per runner. And my understanding would be that this would be to increase low-end velocity, which by speeding up the air, and then it becomes relatively unencumbered when you hit the top end. Now, thinking about it now, for what we're doing, it might actually be a problem. But then again, the head is ported that way, so it's irrelevant. So anyway, so this is taped off. I've got the shop back gorilla taped to the intake manifold. And I've decided that because the jets, they looked real big in the pictures, but they'll be definitely small enough to facilitate, tight placement. And that means I can only do 2. These meth kits, I've only seen them operate once, and it was on an older controller. But from what I remember, the atomization and then therefore the homogenization of the fluid into the air is the quality of that is going to go down dramatically as you reduce pressure at the jet. And so if I were to run many jets in order to get a decent, close to a stoic burn and keeping the thing on at all, I'd have to run a super low pulse width at the pump. And I'm pretty sure that's going to cause puddling and poor performance. I want the pump to come on at a decent hit and be able to carry through. And to do that, I need to, the theory is to reduce the amount of nozzles. Fewer nozzles means a higher pulse width, which means better atomization. That's my plan. So with that said, the thinking, because I'm going direct port, this is sketchy and probably not, man, if you're doing this DIY, this is probably not the way to go, because you're playing with fire doing this, but it's kind of my thing. So I'm gonna go in between the 2 runners. On each side, they're symmetrical. I got my punch. And yeah, I'm just gonna load them in. I have a tap kit to tap to his 1/8 NPT. And then, yeah, I mean, it's pretty straightforward from there. You just tap it in, and then I'll probably add something to seal it. Just, to be sure, because that's a lot of pressure on those threads. But luckily the hole's small enough, the actual pressure on the assembly won't be too bad. But regardless, I will post when it's done. Okay, I'm just gonna pump through a few of these. Just it's actually going pretty well, so I figured I'd keep going. If you don't have these for your taps, get them. They're amazing. It lets you use hand tools for your taps. Way easier. But yeah, I'm gonna crank the vacuum on, which also worked great. And then I'm going to tap the hole. And it's gonna be little by little. So I'm gonna tap with these NPT, these pipe threads. They're graduated, or whatever the one means that gets bigger from the base, tip of the base. And so you have to be careful of your threads, because you want it to bite and bind down on it. And if you keep going with the tap, you'll overdo the hole and it'll just be loose, and you'll have like a nut assembly thing, and then you end up JB welding. Ask me how I know. Okay, this is what I'm talking about. I mean, on the good side though, I didn't do enough, so it's already tight, but it's barely in. So I need to give it a little bit more, and then it should be good. Okie dokie. So this is the final product so far. You might be able to tell from the video, but I've got a small degree issue. It's hard to see, like, there you go. It's about, I'd say I'm probably 5 degrees off total. I mean, I don't know. I'd be lying if I said I know what difference that'll make, but I did get EGTs for per runner. I have 4 that are gonna go in there. You know, and my assumption is that it shouldn't be a problem. The real problem, and if you're like me and you've been around the block, you're thinking to yourself, this is gonna rocket these things square down to the channel. I'm gonna road stake the ground with AEM nozzles when this thing hits like 25 pounds. It's just gonna shoot it out. There's no way, not even with epoxy or anything in there. I mean, I'm gonna go for it because this is the plan. And like, you know what I guess I could do is like, I could probably build a lock system into the ribbing that, you know, really simple, you know, just, you know, goes over it or something. I don't know. I don't want to get too complex. That wasn't ever part of the design. But then again, like, the alternative is just going to a plate design, which would be maybe easier, but ultimately less stealth because you can really see in to the, you know, the front end. So anyway, that's the issue right now I've got to concern myself with. And then the final part is how I'm going to end up doing the routing for the fuel, the lines. I think I'm going to go right through the bracing, the webbing. Circles make things stronger. So if I add circles to the webbing, the intake manifold will get stronger and I'll make even more power. So this is science, and you have a good night.